in this lesson, we're going to talk a little bit about enthalpy. And enthalpy and the process of removing heat from product is exactly what we're doing in refrigeration. Okay, enthalpy is the heat content of a product. Refrigeration, we have to remove heat from products or products, multiples, to get a cooler or the product down to where we can store it, process it, or work from it. So it's all about BTU removal in refrigeration. So we have to know for any certain food that we're going to store, any certain product, we have to know how many BTUs we have to remove to get the product from one temperature to another. We also have to know the freezing point of the product, because at the freezing point there's a latent heat change. So the enthalpy worksheet that we've given you in your course has to do with this. So I'm going to walk through a couple examples here. I'm not going to do the entire worksheet for you because it is sort of important practice. So let's take a look at the first one. Okay, how many BTUs will it take to get 300 pounds of apples from 58 degrees down to 0 degrees? Okay, so we know it's apples, we know it's 300 pounds. Okay, so let's go to the enthalpy worksheet that I like to use. Okay, and we're going to start off by saying, okay, we know we have 300 pounds, right? Then our starting point, okay, is 58 degrees. Our ending point is 0. So we start at 58. We're going to end at 0. Okay, but first we have to find a freezing point. Okay, so what we have to do is we have to go find a product heat load list. Now we're giving you one here, okay? So we're talking about apples, okay? Fortunately, apples are the first thing in the product list. Our freezing point of apples is 28.4 degrees. Okay, so let's go ahead and just fill that in real quick. Okay, we know our freezing point is 28.4. Okay, now, we also have to know what our specific heat is, above and below freezing. So let's talk about this table here real quick. Okay, we're starting with 58 degrees. Our latent heat change is 28.4. We come out of the latent heat change, we still have 28.4 degrees apples. Okay, our final point is we want to go down to 0 degrees. Okay, so between 58 and 28.4, that's a reduction in sensible heat. That's temperature I can measure. From 28.4 to 28.4 across B in my diagram, that's a latent heat change. That's the freezing process. I can't measure that, but there's a BTU content that's called latent heat. From 28.4 down to 0, that's again a sensible heat. I can measure that. That's a temperature change. So what we do is we know we have 300 pounds in each one of these points. We know we have 300 pounds. Okay, the weight of the apples is not changing. Okay, latent heat change, we don't have a temperature change. Okay, so we basically have no temperature change. From point A to point B is 58.4, 58 minus 28.4. So we'll go to the trusty calculator. Okay, we'll take 58 minus 28.4. And we have a temperature change of 29.6. Okay, we are not taking off latent heat at that point. Okay, in the change of state, I'm not taking off specific heat because I'm not doing a measurement. Then down on my lower portion from the freezing point to 0, I have another 28.4 degree temperature change. Okay, so now how many BTUs per pound of apples does it take to lower the temperature of apples 1 degree above freezing? So if we come back to our product heat load list, okay, product apples, okay, my specific heat above freezing is 0.92, below freezing is 0.39. Let's go fill those numbers in. 0.92 above freezing, and then below freezing 0.38, I think it was, and we'll check that real quick. Sorry, 0.39. Let's go fix that. Okay. And again, I don't have any latent heat change here. Now, for my change of state, which is B 28.4 to 28.4, I do have a latent heat. So what we need to do is I need to come over here. Latent heat is 91.5. So we have 91.5. Okay, what this is basically saying is that for every pound of apples, to reduce the temperature 1 degree, I have to remove 0.92 BTUs. For every pound of apples, to do a change of state from unfrozen apples to apples, I have to remove 91.5 BTUs. For every pound of frozen apples, to reduce the temperature even more by 1 degree, I have to remove 0.39. So once you have these numbers filled in, it's an exercise in multiplication. So you come back to your trusty calculator. Let's clear off my last number. We do 300 times 29.6 times 0.92. 8169.6. So here, 8169.6. Then we have our latent heat change, 300 times 91.5. So again, we'll come over here, we'll do 300 times 91.5. Okay, and that is going to give me 27,450. Okay, and then we'll do my frozen apple line, which is, again, let's clear the calculator. 300 times 28.4 times 0.39. 3322.8. So the total heat I need to remove to do this whole thing from 58 degrees to 0 degrees apples, you're going to add this total BTU column. So we have my 3322.8 plus 27,450 plus 8169.6 comes to 38942.4. So 38942.4. Okay, so what this is basically doing, and let me just verify that number, 38942.4. Okay, so it takes 38,942 BTUs of heat to cool 300 pounds of apples from 58 degrees to 0 degrees. Now, that comes into play when we're troubleshooting equipment. Let's say a customer calls in and says, my cooler isn't cooling off properly. I got a shipment in and it's taking forever for it to cool off. Well, it helps to know what the heat content is you're actually trying to cool. If you're trying to cool this in an hour with a 12,000 BTU per hour system, you're not going to do it. It's going to take over 3 hours to do the cooling. Okay, if you're going to cool this in an hour with a 40,000 BTU per hour system, yes, you can cool this within an hour. So that's why this one is sort of important. So let's do one more just to make sure we got this. Okay, Let's go ahead and do the 280 pounds of oranges from 75 degrees down to 35. Okay, 280 is my weight, 75 is my starting point, 35 is my end point. So let's go back over to my enthalpy worksheets. Okay, so again, we have 280. We have a starting temperature of 75. Okay, and my ending temperature was 35. So let's go ahead and we're going to write that ending temperature right there down there. So we have 35. Actually, we're probably not going to cross a freezing line. So I'm going to put that right there because I don't think 35 oranges freeze at 35 degrees. So let's go verify this. I have oranges. Okay. I'm going to take my oranges. Okay, my freezing temperature is that column over there. My freezing temperature is 27.9, so we're not crossing a freezing. My sensible heat column is that one right there. It's above freezing, so it's 0.89. Okay, so what we have to do, this one becomes real simple. So I come back over to my enthalpy sheet, okay, and we put in my 0.89 for specific heat. Okay, we have 280 pounds of oranges. We have a temperature difference of 75 to 35, so that's 40 degrees. We have no latent heat. So we go back to the trusty calculator. We take 280 times 40 times 0.89. Okay, so my whole, it's 9968. So my BTUs I have to remove in this whole process is 9,968 BTUs. There's nothing else on this. So my total removal of BTUs to get 280 pounds of oranges from 75 degrees to 35 degrees is 9,968 BTUs. So that's how foodstuffs work. Now there's one interesting thing I want to point out to you. Water. Okay? Water is actually a pretty interesting issue here because waters are what we consider a reference substance. The sensible heat with water is 1. The sensible heat with frozen water is 0.50, and my latent heat of water is 144. Okay, so these are numbers you sort of want to remember. So again, okay, so when we deal with water, okay, if we have BTUs, how many it takes to get 400 gallons of water from 175 degrees down to 10 degrees, the first thing we have to do is deal with weight. Water weighs 8.33 pounds per gallon. So let's come over here to just do one of these real quick with water. Okay, so we have 400 gallons times 8.33 equals, and we'll pull out the calculator because it just makes more sense, 3332. So 3,332 pounds. Okay, we take a look at the worksheet again. Start temperature is 175 degrees down to 10 degrees. Okay, so we have 175 degrees and we need to go to 10 degrees. Below zero. Okay, now, so let's go ahead and put my temperatures in. 175, we know water freezes at 32, so we have 32, and then we down here will go to a negative 10. Okay, so My latent heat, I might as well fill in while I have it in my mind as 144. My specific heat above freezing is 1.0. My specific heat below freezing is 0.5. Okay, we know in my change of state process I don't have any specific heat. We know in the without change of heat I don't have latent heat that I'm pushing off. It's all sensible heat. Okay, so we'll just fill those in. So we might as well fill our weight in because everyone, the weight is the same, 3332. Then I'll come down to 3332, 3332. Okay, my temperature change, 175 minus 32, okay, is 143. I don't have a temperature change between 32 degree ice and 32 degree water. And then 32 minus negative 10 is 42 degrees because two minuses together, 32 minus negative 10, it equals a plus. So we take 42. Okay, we multiply across. You will pull our trusty calculator out again. 3332 times 143 times 1 is 476,476. 476, 476. Okay, then we'll do my latent heat. 3332 times 144, 479,808. Okay, and then we'll come and do my sensible heat below freezing. What has changed? Okay, is my specific heat is basically a 0.5 now instead of a 1 because its temperature is below freezing. The BTU content is less. Okay, so we do my 3332, which is my weight, times 42 as my temperature difference, times 0.5. So we get 69,972. 69. Okay, to find the total BTUs I remove, we take my 69972, add 479,808, plus 476, 476. Okay, so in order to do this, I need to remove 1,026,256. So my number is 1,026,256 is my total BTUs I have to remove to cool 400 gallons of water from 175 through my freezing point of 32 down to 10 degrees below zero. Now, you're not going to do that in an hour. That's going to be a multiple hour process unless you have one big compressor. So hopefully this little short recap shows you gives you a better idea how to do these enthalpy worksheets.